In this video, we're going to look at hydrocarbons and homologous series of hydrocarbons in a bit more depth. So first question, as the boiling point of a hydrocarbon chain increases, what happens to the length of the carbon chain? Well, the longer the chain of carbons in a molecule, the higher the boiling point of that substance. So longer chain, longer carbon chain equals higher boiling point. Next, the carbon chain can increase by one carbon each time. How many hydrogen atoms will join to this carbon? Well, have a think about it. Let's just draw a couple of a carbon chain there. This is ethane. Now, if we were going to lengthen that carbon chain by one, we'd have 3 carbons instead of 2. So let's do 3 carbons. Okay, so that's that carbon there. That's this carbon here. That carbon there is that one there. So we've added this one carbon in the middle. Now, carbon forms 4 bonds. It's got 1, 2, 3, 4. So we're adding 2 hydrogens. We're adding a CH2 every time we add a new carbon. So the answer is 2 hydrogens. Okay. When we have 2 different compounds which have an identical structure other than the number of carbon and hydrogen atoms present, like these two. These are identical other than that this one's got 3 carbons, and this one's got 2 carbons, so this has actually a couple of hydrogens as well. They're identical, aren't they, apart from a CH2 group. These compounds are said to belong to the same homologous series. So in other words, they belong to the same family of compounds. They look very, very similar indeed, apart from a CH2 group, that CH2 group in the middle there. Okay, look at the 6 compounds below and then answer the questions. Which of these carbon-based compounds are hydrocarbons? So we've got 6 compounds here. Which are hydrocarbons? Well, a hydrocarbon is a compound made of carbon and hydrogen atoms only. So if we look at this one here, number 5, only carbon and hydrogen, same as number 3. Number 1, there's an oxygen in there, so that is not a hydrocarbon. Likewise here, all carbon, hydrogen, all carbon, hydrogen. This one has an oxygen as well, so that's not a hydrocarbon. So the answer is 2, 3, 4, and 5. 2, 3, 4, 5. How many different homologous series are there? And which compounds belong to which series? Well, if we look at this one with oxygen starting, that's probably fairly obvious. So this compound here is exactly the same as this compound here, just this one has got 4 carbons and this one's got 2 carbons. Obviously there's an extra 2 hydrogens on each of the extra carbons. But they've both got the same functional group. A functional group is something that's unique to that molecule, this OH group. Both got the same functional group. So these are the same homologous series. So 1 and 6. Number of homologous, that's 1 and 6 there, isn't it? That actually is called the alcohol family. Now, if you're a double award scientist, you don't need to know that. If you're a triple award scientist, you do need to know that. Okay, so that's the first one. So I should really say that's number 1 there, shouldn't I? Number 2 then. Number 2, right. Looking at these compounds at the top here, we've got a couple of these compounds in this homologous series. This is ethane, C2H4, and this is butane, C4H. 10, C2H6 and C4H10. Those 2 are the same homologous series. So number 2 is is molecules 2 and 3, yeah, and they are the alkanes. There we go. So it's our second homologous series is number 2 and 3, and they are the alkanes 2 and 3. Right, our last one then. Number 5 has a carbon-to-carbon double bond. That's its functional group. Number 4 has a carbon-to-carbon double bond. So our third one is number 4 and 5, and these are the alkenes. Be really careful when you write alkane and alkene because it's only 1 letter difference, and it's actually quite easy to confuse an A and an E. Crude oil contains many members of the alkane homologous series. What is the general formula for the alkane homologous series? So the alkanes, as this one's here, the ones with a single bond. So all the molecules in crude oil are alkanes. The only difference is they've got different numbers of carbons. So what's a general formula? A general formula is a mathematical formula. If we know the number of carbons, it's going to tell us the number of hydrogens. Okay, so if we look at this, if we've got, say, 2 carbons, every carbon has a hydrogen above and below it, doesn't it? So for every carbon, there's double the number of hydrogens. For every carbon, there's double the number of hydrogens. So we could say Cn, where n is any number, H, 2n, or 2 times n. I'll write it 2n, but there's a multiplier in maths, isn't there? So I mean, you could write it out. CnH 2 times N. You see? So that's the same, how I've written that. But also, there's a hydrogen on either end. So when you get to the end of the chain, there's always a couple of extra hydrogens left, so we need to go plus 2. So it's Cn, H2n plus 2. Cn, where n is n, but H2n plus 2. So let's just give it an example. Let's just say we've got a molecule with 30 carbons. Well, 2 times n, 2 times 30 is 60, H60, plus those 2, plus 2, plus 2, so it would be 62. So if you've got 30 carbons in a row, you'd have 62 hydrogens around it. Okay, next question. Give 4 reasons why compounds 1 and 6 are in the same homologous series. So compounds 1 and 6, this one here and this one here. Remember we said they're identical apart from the number of carbons and hydrogens. Okay, well, just to help you out here in the way the book is written, if you go back to the start of this chapter, okay, this is topic 8, fuels and earth science. Now, the exam board provides me as a teacher is a list of things I have to teach you. I've kind of rewritten those just slightly, just to try and make them a little bit more understandable to students. You may disagree, I mean, you may think them less understandable, but they're a really good list for you to revise from. And if you don't know an answer, a really good list for you to find things from. So number 1 says, learn that hydrocarbons are compounds that contain carbon and hydrogen only. So if you understand that, you can tick it straight away, and then your next job is to learn it, and you can tick that. This is why it's a good revision list. Well, come down here, and you find something about, you get to number 6, it says, learn the homologous series is a family of hydrocarbons with molecules of the same general form. In fact, there's 4 different things here, aren't there? So give 4 reasons why compounds 1 and 6 are in the same homologous series. Well, they have the same general formula. So basically, we're just writing these out because you've got to learn them. Okay, chemistry is a very honest GCSE. If you learn what you need to learn, you will get a very high grade. Number 2, the difference CH2 and molecular formula. They only differ by CH2. Basically, as you add a carbon, you have to add a hydrogen above and below it, and that's how the formula differs. Number 3, have a gradual variation in physical properties, for example, boiling point. As the chain gets longer, the boiling point goes up. Gradual variation. Gradual variation in physical properties. And number 4, they have similar chemical properties. Chemical properties. So in other words, they react in the same way, similar chemical properties. And that's how homologous series are all the same.